Hello, students. Whew, how you doing today? I'm still here in the lab, drinking my Coca-Cola Cherry Zero and working a little organic synthesis. In fact, I've heard about that there's this website Twitch where gamers, sort of live stream their games. And I checked it out, and apparently it doesn't just have to be gaming, it can be other stuff too. So I've opened up myself a Twitch account so that all of my followers out there can watch me doing some organic chemistry. Apparently I'll get paid or something like that. I think it'll be sweet. I'm Ochem Mac Daddy 23 in case you're trying to find me on Twitch. So look me up. Can't wait to see you there. I'll be there tomorrow night live streaming some organic synthesis. Can't wait. Until then, here's a little walkthrough of some organic synthesis gaming that I've been doing recently. This is OS3, the first three problems, number 1, 2, and 3. So check it out if you need some hints or tips on how to solve these exercises. I'm not going to write out the complete solution. If this were a test, I would want you to actually write the reactants and the organic products for every stage, write out the full-on name of the reaction, and all that good stuff. This is just like a little shortcut version, right? So I'm just going to throw up real quick some hints for how to solve these. Let's look at the first one, right? So I'm looking at this. I'm looking at this for number 1. I'm seeing, hey, those carbon skeletons are the same. I don't have to do any Grignard or any fancy alkene oxidation. I just have to fix the functional groups. I notice right now, all I have in the reactants are haloalkanes, but they're different kinds. One's primary, one's tertiary, right? So I know I can throw down some hydroxide. If I put in some hydroxide, it's going to affect those two groups differently. This one is going to be substituted because it's primary. Notice how elegantly I wrote the H on the outside so it doesn't look funky. This one being tertiary, right, in the presence of hydroxide, this one's going to be eliminated, and we're going to make a double bond. There's lots of different double bonds possible. I'm just going to put one in here because it doesn't matter, I'm going to get rid of it anyway. So this is SN2 and also E2, both simultaneously. You can put those both in the same step, right? Because they're both happening at the same time. Step number 2, got to get rid of this puppy. That would be H2 with your favorite catalyst. I know Evan is out there and he likes to use palladium because it's super expensive and fancy. So finely divided palladium with carbon, Evan, would be a fantastic choice. Or platinum if you prefer. That of course is MEA. And that will get rid of this. Last but not least, we just have to oxidize this puppy. Gentle's not going to do in this case. We need powerful, which is that dichromate in the presence of H+. Did I say reduction? I meant oxidation. We got to do some oxidation. We need more O's, right? So oxidize this sucker to here, and bam, we're good. Let's go to number 2. Uh-oh, starting with an alkane, or more precisely a cycloalkane. And we got something over here that has functional groups. Anytime you're starting with an alkane and nothing else, you only have one choice. Well, 2 really, you could burn it if you need some carbon dioxide. But the only other, the choice we have is free radical chain reaction. This is a relatively large molecule. How much of a problem is that? And the answer is, it's somewhat of a problem, but in this case, not a huge problem, because even though we will get some where you have more than one halogen added, like 2 or 3 or 4, how many different monohalogenated products will we get in this case? Answer, only one, right, because it's a ring. I like chlorine. Don't forget to throw in some benzoyl peroxide. Make sure you know how to spell that, or some UV light. That'll get you one. We don't need one, just chlorocyclopropane. Step 2. All right, what's going down over here? Well, what we have here is an ether. So I know I need a haloalkane and also an alcohol. This ether actually works better if this is the the ring is the alcohol, because then this 2-carbon bit isn't sterically hindered. But we'll go ahead. You know what? The easiest, cleanest way to do this is probably to add a little LDA. You remember what LDA does. It's one of the secret reagents. LDA will eliminate that and make this. So that would be an E2. Now, I'm going to put down some water, an H+. That, of course, is MEA. What that will do is make all of that into an alcohol. We could have converted the haloalkane directly into an alcohol, but because it's secondary, we would get some elimination if we just went right from here to here, right? So this is maybe a little bit cleaner. We don't get any side products from this. Now, we can add our 2-carbon haloalkane and some sodium or potassium. Add some Williamson ether synthesis, and boom, we're done. There's more than one way that you could do this, but I kind of like this. This is nice and clean. Last but not least, number 3. I'm gonna do some retrosynthesis. Retrosynthesis means look at the end and work your way backward. What I notice is this carbon skeleton is the same as this. But what I have here is an ester. So what I know, my last step was probably forming that ester. So I'm gonna pull that apart, which means I would need, this is, remember, the alcohol side. This is the acid side. All right, so that's where I'm going. I need to convert this into this. So step 1, I'm gonna make that into an oxygen group with a little OH minus. That's some SN2. That makes this an alcohol. So far, so good. Now we gotta oxidize the heck out of this with dichromate, oopsies, and H+. Once again, that's that same, where to go, powerful oxidation. Bam, that gets us that. Now we're almost done. What is that reaction that combines alcohol and acid to make an ester? Fischer esterification, named for Emil Fischer. So we need our good old Fischer esterification. Remember, the catalyst for that is H+. You all did that reaction live and in person in this room when we made the juicy fruit banana oil honeybee alarm pheromone. Remember that? Oh, good times. Remember back when we were all together and we had a class together? I miss those days. Anyhow, you just need to add, this is a new reagent, methanol, to your acid, and bam, you're done.